Awesome.
Recording to the cloud. Welcome everyone to today's edition of Usage Metrics Collector sub-project meeting, not the regular SIG instrumentation. It is Wednesday, February 8th, 2023, and I believe we're going to kick it off with a very exciting demo, and then we'll follow up with a presentation, and we'll have opportunities for people to ask questions. Today is going to be a deep dive on the Usage Metrics Collector sub-project. So Phil, please take it away with the demo.
Sure. I'll just start with the demo here. So I'm going to start out with just the end result, which is like this, in this case, Prometheus instance. I got a cluster running over here. It's just a random GKE cluster I created. Nothing too special about it, except it's using cgroups v1. And so I deployed our application with kube control apply, import forwarded, and I got this Prometheus instance running as part of it. And so this should be pretty familiar to everyone here. What's interesting, I think, is that these are the new metrics published, or here are some of the new metrics published by the collector. And these are the utilization metrics, which are kind of the more interesting of them because they're the ones that you don't get quite the same thing when you're using kube state metrics or C advisor. So for instance, we have the max utilization for a workload as one of the metrics here. And so what this one is it's at a 1 second sampling. So you sample every second, the CPU in this case. You get 5 minutes worth of samples, so that's 300 samples. What was the max sample over that 5-minute period? And so in this case, and then the workload name here. And so you'll see here it has the container, right? So you can look at, in this case, there's just the one container. And then various other labels associated with this particular workload. It's running as a daemon set. This is the name. And so within all the containers, in this case, or with all the instances, so there's the 300 samples per 5 minutes, and then there's the various replicas, I think 3 replicas, one for each node, right? And so in which case you have 900 or so samples every 5 minutes. What was the max sample that we saw? Right? And so then that's about 0.1 CPU, 0.09 CPU. Right, but then you also have these other ones, which are like, what was the P95 sample of those 1,000 or so? What was the median of those 1,000 or so? And what was the average of those 1,000 or so, right? And so you can see there's like a pretty big difference between the max sample of all the nodes and all the seconds and kind of the average down here, which is closer to what you typically get if you'd be sampling every 5 minutes. So this is, and it automatically does the walking from the pods into the workloads to resolve all the replicas and such. So that's kind of like, I think, one of the more interesting examples of what this can do. One thing it's doing as well is, I just wrote this code isn't checked in yet, but I wrote it just kind of for the demo. What happens if we take those samples and upload them to BigQuery, for instance? And so every time it samples, it goes and pushes that set of samples into BigQuery. And so that allows you to do kind of interesting analytics on, searching for workloads that are maybe poorly tuned, or what are your workloads that are having the highest requests, or what are workloads that are using, really requiring on their limits a lot more than maybe you want. And so in this case, I just did a pivot. And so it just has a sidecar that dumps that data into BigQuery. I also have it dumping into the cloud storage over here. So if you want, for instance, to do other sorts of analytics, I think a lot of what we're trying to do is making it like, how do we make it simple to do sophisticated stuff with this that maybe PromQL queries are just, not well situated to do. Oftentimes, you get, if you want to look at maybe 30 days worth of data, doing something sophisticated in PromQL it starts to hit its limitations. And so that's why having archives of this data or putting them in queryable sources gives you capabilities that you wouldn't otherwise have. And then, yeah, that's kind of the main bits. I can maybe just walk through quickly, what's going on here. So we got a couple samplers here. These are the things sampling on each of the nodes. And then we got this collector, which does the aggregation in our Grafana and Prometheus instances. And so you can do something like this if you want to just debug and see what's going on, you can just, of course, curl that collector instance and it'll dump all this stuff out there.
So Phil, just to avoid defining things by like their name. So the node sampler is the thing on each of the nodes that is looking at all of the workloads and collecting utilization metrics. And then the collector is the thing scraping those samplers and doing cool aggregations on them, right?
Correct. Yeah.
Great. I don't know if that helps anyone, but I heard like the sampler is sampling, and I'm like, yes, I know exactly what that means. You might.
Yeah, hopefully looking at the pods, maybe you got an idea of the daemon set. But yeah, that's correct. Yeah, the architecture, but you're probably going to go into architecture in your presentation, right? Of how we actually do that set of samples.
Yes.
Any
is it time to
questions?
share my? Yeah, sure. I'll wait.
Questions before we go into the presentation?
Yeah, actually, I have.
Let me quickly just say the question in chat. How are metrics data exported into BigQuery? Does it upload metrics data file into BigQuery? So
Yeah,
I think
that
you said you
was-
hadn't committed that code yet.
That was done like as I was like, what would be cool to do as part of the demo, right? And so I wrote a script that just uses the Golang BigQuery. There's a load API that loads JSON, and the trick there was that you have to update the schema. So one thing with BigQuery is if you add a label, right, to your metrics, and then you try and push that into BigQuery, the query has to have those additional labels. And so it basically just reads so the collector dumps, there's an option in the config for the collector to dump out a JSON file each time it does a collection, right? And so that JSON file is actually a format that BigQuery can read natively. It's just new line delimited JSON blobs of the metrics. And so what we do is what that sidecar does is just reads those files, lists the directory every minute or so, reads those files, looks at what all the labels are, infers the schema, and then sends a load command to BigQuery with that schema. And then it will automatically, if you do that, you can set an option to automatically update BigQuery with the new schema. That same sidecar is also what pushes it into GCS.
We have another question in chat, but first, Han, you had a question?
Yeah, I was just wondering, like, what kind of cardinality have you tested? Because workload names are unbounded, and you could theoretically have huge clusters, right? With many.
I'll say the workload names tend to be smaller than the pod names, which is what we had to do before. So we're like, if you look at what we're trying to replace, is doing a C advisor lookup of all the pods, joining the utilization of that with the pod info with KSM, then with the pod labels from KSM, then with the node info from KSM, then with the node labels from KSM, right? And the namespace labels from KSM, right? And you're basically doing a massive join of all the pods, and so if you look at, I'd say we're looking at more at the cardinality that we're reducing, right? Which is, orders of magnitude, maybe 100x in terms of just the operations and sophistication. I'm gonna refrain from saying the exact cardinality just because I can't remember what we're pretty clear to talk about in terms of what we're doing.
Fair enough.
So, question in chat, which I think was just kind of covered. maybe this will be covered later, but to what degree is this intended to replace cAdvisor metric collection? It doesn't need to entirely replace it, but it can be used as an alternative mechanism to cAdvisor. It looks at the same things that cAdvisor does, but is a little bit less CPU intensive, and only because it only looks at a small subset of what cAdvisor can collect. It's just looking at CPU and memory. It's not looking at all of the other stuff. cAdvisor looks at a lot of things. So, so you can use it instead of cAdvisor if those are the only things that you care about. And then you don't have to do all these joins with cube state metrics as well, as Phil said.
It's meant to replace doing the thing with cAdvisor that people really hate doing, which is those really complicated joins across really high cardinality data to get like the workload one I demonstrated, for instance. Like, how do you figure out the workload? Well, then now you're joining with the owner's reference, but the owner's reference from KSM it's like, in order to walk replica set, like how do you walk from pod to replica set to deployment, maybe something higher? It's actually really, really complicated query to do. And so I'd say the scope of it is limiting it to replacing the pieces that cAdvisor really isn't trying to do. It's not, would I use this to replace, like, the one thing cAdvisor does is, like, I want to debug a pod because there's one pod that's has too much CPU, just one pod, not the workload, right? Not broader patterns. We categorically have said that's really not what we're trying to do. And so for that use case, I've advised people, continue to use cAdvisor for that. Don't come looking at our things for it.
So we do have one more question in the chat, but I think that one might get answered in the presentation. So why don't we go and do the presentation, and then we can come back to Q&A. I also wanted to let folks know, like, I'm happy to read your questions in chat, but also, like, feel free to put your hand up and you can unmute and ask the question as well. But without further ado, Abo, you want to take us away with your presentation?
Sure thing.
Beautiful.
All right, just needed that button. Can everyone see my screen? Sweet. So just a little bit about the design of the collector. So the main piece is the actual collector itself. Let me find my mouse here. I can't find it. Oops. Where is my mouse? Why does my mouse disappear? Oops. Oh, I guess I can go in presentation mode because I can't see my mouse. Anyways, so the main piece is the collector itself. It takes in a config, and I'm gonna delve a lot deeper into the config because it's how it sets up all the aggregations that Phil showed. So for example, you would set the resources, the extension labels, the aggregations themselves, the local samples that Phil was pushing to BigQuery, sidecar metrics, and so on. And the second piece is the node sampler. That's what actually gets utilization metrics from the nodes, be it using containerd or crawling the C groups file system. And also you have a controller piece. That's what gets your resources from the API server to get maybe requests allocated or your limits and quota and so on. And this collector is also a Prometheus exporter because you want to expose all the metrics you aggregated via a metrics endpoint. Please interrupt me if you have any questions. I can go over those. All right, let's see if we can do this. So a little bit about the node sampler. It runs on every node. It pushes metrics to the collector. So you have metrics like CPU, memory, CPU throttling, boom kills as well. And so the first kind of set of metrics it pushes would be the container metrics. So you can get those by walking the sysfs C groups. But it also supports getting metrics via the containerd socket if you have a pod runtime, like for Kata containers, where you can't get that by walking through the C groups. So then you also have node metrics by C groups. So you can kind of glob at different levels and get metrics for those as well. And this is a config. You can pass this, the globs by config. I'll mention that a little bit in the next slide. So this takes some configurations. The buffer size, for example, Phil was showing 1 second sampling and buffer size of 5 minutes, so 300 samples. That's also configurable. How often you push to the collector is configurable as well. And also the node level globs I mentioned in the previous point. All right, so the metrics collector itself. So we have that config I talked about. Here you would specify what resources you're interested in, what are the sources of the metrics, the aggregations and the extensions. I'll go deeper into that in a slide ahead. There's also the aggregation engine that actually performs the aggregations and exposes those metrics as well. And then you have the controller that would list the resource quota to get other sources from that in pods, nodes, BVCs, or namespaces. And then you have the exporter piece that actually exports, exposes the metrics endpoint that you could scrape. All right, so the config, where all the magic happens. So the first thing in the config is the actual resources you're interested in. So for example, you have CPU, memory, storage, and there's a resource type called items. For example, if I'm interested in a metric on maybe an IP class on a pod, and I want to count that in a namespace, so how many IP classes are being used in some namespace, I can expose that as an item, which is essentially a count. All right, so you also have extension labels. So these are labels that are not built in. For example, container name, pod name, those are built-in labels. But what if I want a label that is maybe a Prometheus label that is an annotation on a label on a pod or a namespace or a node, or even a node taint. So for a container running on a node that has a taint of no schedule, I want to have that label in that container metric. So I would use these extension labels to get that. And then you have aggregations, which define the actual sources where you get the metrics and how they get aggregated and how the metric that actually gets emitted for those. And then you also have something called sidecar metrics. So if you have metrics you want to expose that are not part of the collector, you can also use a sidecar to write those metrics to disk and rotate them. And then you just pass the folder to the collector and it'll expose those metrics as well. And then this is the part that relates to the BigQuery piece or GCS or whatever object store you want. So you can also save local samples for the metrics in either protoform or JSON to disk. Okay, that's it about config. Let's talk a little bit about aggregation. So sources. So your sources are just where your metrics are actually coming from. So you have different types here. You have containers, C groups, pod, node, quota. And for each type, you have different sources in that. So for example, here for a quota, I might be interested in resource quota hard or quota use. For container, I might be interested in the allocations or the limits. All right. So then you have, for the aggregations, you also, oops, what happened there? Oops, sorry about that. Okay, there you go. You also have levels, and this is kind of where the aggregation actually happens. So for a level, you have a mask. So a mask is just a set of labels and a level name that determines what metrics are going to get aggregated for those label values. And so for that, you have the built-in labels, and then this is where you pull in those extension labels that I mentioned before. And then you have an operation, because you have these masks that specify what labels you want to aggregate over, and you have the actual operation that's going to get applied to the samples that get aggregated. So we currently averages some median mean P95 is supported, you can also do histograms. And for histograms, you have to specify kind of buckets so that these your samples can be correctly aggregated into these histogram buckets. And there's a no export. This controls if that level is actually exposed as a metric. As Phil alluded to, maybe you don't want to expose container or pod level metrics, but you want to do those aggregations. So you would just specify the aggregation and then add the no export true, and that does not get exported. So then you have a retention name. This relates to the local samples. If you want to expose one of these levels into the local samples that get written to disk, you would just specify the retention name. All right, I have an example here. So here's an example of an aggregation on a container type, and I am interested in utilization and requests allocated for that container. And so my masks are, I want my first aggregation to be on the container. Here are the built-in labels that I'm interested in. Maybe container name, namespace, the pod name, priority class, and the node that container is running on. Then for extensions, maybe I want to know about the taints on the node that container is running on. Maybe if it's no schedule, I want to know about that. And also if I have an annotation on the node that specifies a node pool, I also want to include that here. And then I have no export true, meaning operation is average, by the way, so it averages all the samples that matches the label values. And then I don't want to export this metric. And then the next aggregation level will be the pod. It's just the same thing. It's just missing that container name. And then the operation here is the sum. So I want to sum all the containers that belong to that pod. So if I look at the metrics that come out of this, let's assume that our resource here is the CPU, I would have something like that. Depending on what prefix I set in my collector, I would get this prefix. I'm just calling that cube usage here. Then this pod name is the mask name I had here. So just say pod, and this is that operation I use, so sum, and this is the actual source itself. So request allocated, and this is the resource I'm measuring. So that'll be CPU cores. And those are the labels that are pulled from the built-in labels and the extension labels. The same thing for utilization as well. And that's it. Any questions?
Okay, so just coming back quickly to how use question. Did the presentation answer your question?
Oh, yes, perfect.
Uh,
Thanks.
and Ty, I think, did you want to unmute and ask your question? Feel free.
Sure. I'm just wondering a bit more about the extensions. The current way I'm understanding it, which might be wrong, is, you mentioned like labels and annotations can be looked up. So under extensions, whatever key you specify there is going to be, it's going to be looking for a matching key in annotations or labels. Is that correct? And then I'm also wondering, like, if you would have an annotation and a label with the same key, is there an order to kind of which gets checked first?
I can probably just show quickly what it looks like, and it might answer. All right, can you see this? All right, so like this is an example of the config. So let me just reorient everyone. These are like the rules that ABOT was showing, right? And so the way we've written our config, this is the open source repo, by the way, right? We kind of document, these are what gets produced by these sorts of things, and you can see them building on one another here, right? And some of these are histograms and whatnot. And so if you look up at the top, this is where kind of the extensions are here, right? And so these are all commented out. I don't have any extensions enabled, right? But let's say I wanted for all the metrics derived from pods. So that's like, the pod metrics if you have them, but like workload metrics, app metrics, namespace metrics, like for the sum of utilization of a namespace, cluster metrics, like all these sorts of things. I would say, okay, whenever I am building that metric, go look for this annotation or this label on the pod, right? And so if it says annotation here, I'm looking for an annotation. If it says label here, I'm looking for a label on the pod, right? And then I say, okay, create the label on the metric, right? So not the label on the pod, but like the metric label named this, right? And then copy the value from the either pod label or annotation label, if it exists, into this new label, right? For namespace labels, it would look like this. And so this applies to any namespaced object, right? So if I apply, let's say I put in a label on a namespace that calls it, project cool or something like that, right? And I want to track all project cool namespaces together in some way, right? Then I'd say, okay, go find the label on a namespace project cool. And when I'm doing pod level metrics, I look up the namespace of the pod. So we do the join here, right, in memory through kind of the informers cache. Get the pod, get its namespace, look for the namespace label. Does it have project cool? If it does, copy that over to this label. Same thing with node labels, right? So get the pod, get the node it's on. Maybe I want to find certain nodes. I have different node pools in my cluster. And so I want to, get metrics, oriented around which node pools are full versus empty or something like that. Or what's the utilization of different node pools, or which node pools tend to be more highly, have higher requests, or those sorts of things. I'd go get the pod, get the node it's on, look for the label, pull its label. And then when I aggregate those pod level metrics up into other dimensions, I have these labels here, right? And same thing with the node taints. The taints are done a little differently because taints are repeated in not just a map, but you can do the same thing looking for taints. Those labels then, I don't think I have any examples here, but you could see built in, when you want to use them, there'd be something like this. They appear in here, right? And so say I want to aggregate doing a sum, this is probably the wrong level, but say, here I want to aggregate on one of those labels, right? Project cool, true, right? And so by setting project cool equals true here, when I do the sum, I'm going to retain that label, right? And so I'll now have two distinct groups potentially for this workload, portion of the workload that's project cool and the portion of the workload that's not. Now for this workload, since they're all pods in the same workload, they're probably all going to have the same value for project cool. But maybe for the node pool, right, they might not, right? And so I have half my workload on a node pool, experimental, and half my, or next version. Maybe I want to know what version of the node Kubernetes kubelet, right, for instance, they're running on, and partition my data that way. So this is like the extensibility that, like, we know that we haven't thought of all the ways people are going to need to partition and annotate their data. And so that's why all these are built into the rules of, do you want to do sum? Do you want to do average? How do you want to kind of build up your data? Does that clarify, answer your question about how those labels are found?
Very much, yeah. Just that sort of, seeing them. Okay, it's a key of a definition that explains it.
Awesome.
Hooray. Great demo, great presentation. It doesn't look like we have any more questions in the chat. So I know we promised on our agenda for today, which I didn't link in the chat, but I will do right now. Haha. We had technical deep dive, Q&A. We've done both of those things, but also roadmap. Do we want to talk a little bit about roadmap?
Whoops. Was I supposed to prepare something?
Yeah, I've got something.
No, we don't need to prepare something. Just like
we painted an
generally,
empty tunnel on a boulder, and the plan is that the roadrunner is going to think that's like a real tunnel.
I'd say, there's some things. I think maturity. The big one is going to be around just maturity. How do we make sure that that we don't lose data? How do we keep the collector as resilient as possible? I know that HA has been a challenge to get right. And just looking at different factors there. I think the container D is support versus the C groups path walking. We're want to build more support for that. I mean, it's out there and it's usable. I think it's ready for use, but it doesn't have quite as many miles. I think a big one is C groups V2. We currently just walk the C groups V1 path. Maybe for container D, it doesn't, if you're using container D, it doesn't matter whether you're using C groups V1 or 2, but for the node level metrics, we don't get those from container D, right? The system slice, because it's not running through container D, for instance. We probably want to add C groups V2 support. Those are all.
Clarification on that one. We're using the container DC group V1 API. So like, I think it's specific to C group V1. So we only
Okay.
have C group.
So
V1
no,
support.
so, okay, so C groups V2 for both the file path walking and container D probably are things that would be great to add support for.
Another thing is the sidecar metrics. We'll like to support aggregation on those as well. Because right now you just specify the metrics and they're not, it'll be cool to aggregate the sidecar metrics the same way that we aggregate our metrics natively.
When you refer to the sidecar metrics, which sidecar are you referring to?
So there's an option to specify sidecar metrics by giving a volume drive where the collector can read those metrics from and expose them. So those metrics, they're just read and exposed as is. There's no aggregation on that. So we'll like to add support for that.
Yeah, an example, you might be wondering, like, why would you want to do that, right? And you don't actually have to do that through this collector, right? You could spin up your own service that exports, whatever any metrics you want. But one pattern we found is maybe metadata about the cluster itself that you don't get from the cluster API, for instance, or just other sources of information that you really want exported at the same time. You want to make sure that it's not another separate service to monitor, like one service is down and the other isn't. You start not having all the data. So we found the transactional nature of being like, I got a scrape, then I probably have all the data at that scrape at that point in time, versus a distributed scraping a bunch of services, and maybe at a moment in time you don't have data from one particular thing, but you do for another. Having that is nice. It's nice, not critical, but nice.
So how does it behave right now if like the informer connection is not ready, or the watch is stuck or reconnects? Is there no metrics then for this period of time?
I think, let me try and remember. So like if it doesn't, I think in some cases it will like restart and kick itself. There's I think it will read from the cache potentially as well. It depends on how stale it is. In practice, I think that's been less of a problem. It seems to reestablish itself relatively successfully. It's actually the leases. The big one we found is getting a lease connection, and then that kills then you're like, I guess I'm not the leader anymore, and then you die. But maybe the other one is like also not able to get a lease connection, and so you were fine, your informers were fine, but because you couldn't get a lease, you decided that you're going to be unhealthy. And
the collector can only run as a one instance right now, right? Or can you shard or like scale it up?
That's not true. We tend to run it as one instance because of what I just described. We found more issues with not getting a lease than not getting the informers. You have to really know what you're doing to run it in HA, because you have all these node samplers, right? This daemon set of one per node that are pushing into the centralized collector. And so what you want to have happen is you only want the Prometheus instance, for instance, to be scraping the collector that's getting the metrics from those nodes, right? If it starts scraping the other one, all of a sudden you're going to have this weird flapping of utilization 0, right? And so that's why if you look at the config has like all these readiness and health checks in it, and we make sure that when you run an HA mode, the collector that isn't getting the node samples marks itself as not ready. And so that way it doesn't get any collections, but it's complicated to do.
But you like right now you can only run as HA. You can't like shard the input from different nodes to separate collectors.
I think like it's possible to do something like that. The shard, because like the way the aggregation works, right? Like a big portion of this is doing all the joins, right? And doing all the aggregation. And that's possible because you have like one unified view of everything. And so if you were sharding it, for instance, you couldn't have the aggregation run across. Now you have to do either a hierarchy where you have partial aggregations and then filtering up, or so the answer is no, we don't support that, and that's why we don't.
Would it make sense for all the Cube API data you get from the Informer reflector that is like pods and actually pods and nodes to collect that data inside the node worker, because you then have at least that shard. You don't have one collector that needs to get all pods from a single cluster, because it can get quite big.
I mean, we still need to, it depends on what the goals are. I'd say this has not been a problem for us. I'd say Prometheus, like it's actually really efficient. So it's surprisingly efficient, and Prometheus has a much harder time with the cardinality, right? Because it's only storing the data right now, right? And then Prometheus stores, if you wanted to store 30 days, okay, well, that's actually being a lot more data. So for our focus, that's the bottleneck. If you wanted to shard it, like again, when you do the roll up from pod to workload, like how do you make sure that you can, whatever's doing that roll up has all the pods in that workload? Right. And then let's say you're also doing a separate roll up from like pods to node pools. Okay, well, that one has to have all the node pools. Well, what if like the intersection of having all the workloads and having all the node pools, right? And then oftentimes we really want to roll up to the full cluster level. How allocated is this cluster? Is it full? Is there a lot of emptiness, right? And so something has to have all that. So you'd have to do tiering.
So you wouldn't gain a lot, and it just depends on like, it's only bad if you have like a real big number of nodes and pods. Okay.
Right. And then it's your bottleneck, right? So maybe you have some super awesome, if you're not pushing it to Prometheus, you're just pushing it to BigQuery. Maybe then I could see that being a bigger problem. I would love for someone to come to me and be like, it doesn't scale no matter how much CPU and memory I give it, right? And then I'd be really interested in that.
Yeah, and the reason I wanted is because we've seen metric server, which is also like this one single thing, at certain cluster sizes start to struggle and get it like a lot of mostly memory utilization to a point where sometimes it doesn't fit on a node anymore. And I wonder if that might be some problem. But I think with the aggregation you're doing, it's probably a lot cheaper because you don't have to hold that many massive objects in memory.
Yeah, and we can do, there's actually we have a lot of room for optimization, because right now the way we do the listing, the way the pod list API for controller runtime works is it basically copies the entire pod memory, right? And so we could probably cut our memory in half if we really needed to by just reading directly out of the Informer cache without making copies of the objects, for instance.
So what helped in a lot of also operators I worked on like right now is switching away from Informer if you don't need the whole object, and use Reflector and have your own cache. Or there's the transforming Informer, but it's a bit more complicated.
We could even do that, like drop all the annotations and labels that aren't there. I think one thing we've done, I put in an optimization to in the reflector, like have a transformer to just drop like start clearing parts of the object. And we turn that on, we're like, it's gonna be awesome. We're gonna save half the memory. And then like it's saved like 2%. We're like, F that, just turn it off. Who cares?
I had better results with only the reflector. Yeah.
So yeah, I'd
And
say it's
on
great.
the-
We have the opportunity to do optimizations. We haven't hit those yet. And we still haven't hit scaling limits.
And one last question: the node part is pushing metrics in Proto
Right. It uses
gRPC to the cloud. So in theory, like if somebody would come around and say, "Hey, I want this in a different, I want you to do the aggregation somewhere else or run this in a different format," they could just implement the same API and tell all the nodes to push there.
Yeah, and actually so the daemon set has in it it says like the service it pushes to, right? So yeah, you could absolutely just run that daemon set, change the endpoint and implement the server protocol and you'd be good.
So for example, the BigQuery export, if you only want BigQuery, you could just, instead of having a sidecar, let the node thing push to your BigQuery exporter.
Yeah, in theory, I wouldn't, that's not the way I'd start out because I'd ask, do you really want to push 300? Do you really want to push like that level of granularity of samples? And the answer is almost certainly no. So then you're like doing the aggregations, right? Like,
Okay.
I'd say maybe the more interesting thing I could see you doing is maybe you want to have like less granularity because 5 minutes is too much. And so maybe you want to do something where you're doing averages over 20 minutes, max is over 20 minutes, those sorts of things.
Okay, thanks.
One thing I didn't demo that we also found was really interesting is just getting an idea of holistically, like on the node, how much is kubepods taking versus the system slice? Are these things well tuned? Seeing like when you run on large clusters, just the variance of like, turns out it's not like one size fits all isn't perfect for the system slice, right? And you're either under provisioned or over provisioned, but there's almost no reality where you're perfect everywhere.
So we have,
go ahead.
we got 12 minutes left, just a time check. So we do actually have a decent amount of time. So feel free to keep questions coming at us, or Phil, I don't know if there's anything else you wanted to.
So my favorite part of this project has nothing to do with the project or SIG instrumentation or anything else. That's a little piece of infrastructure we just had to write because we really were tired of writing tests. And so we write our own test infrastructure that Paul and I have really patted and Ava have all patted ourselves on the back about.
Very generously. Major pats.
So I don't know if people are interested in seeing that. Something I could show off in minutes. All right. So the theory is I hate writing tests. What I really want to do is run my code and then say, what's the results of the code? And are they what I expect? Right. And I don't want to write what the results are. And I don't want to write the test. And the only thing I want to write is the input. And so, based on that kind of theory, we said, okay, what can we do to make that a reality? And so we wrote most of our tests are just functional, where we have in the collector here this, these are all directories, and you just create a directory of test data. And so we say, okay, here's a test case. And so for this, we say, here's the state I want the cluster to have. So just load up the cluster with this state at this replica sets, and then our infrastructure looks and finds like something called input client objects YAML and just says, yeah, okay, I'll create the in-memory cluster with that. And then here's the spec for configuring it. So here's the aggregation rules and all the various pieces. And then maybe here's this extra one, other pieces of input that you might need to say, okay, like ignore these metrics because, latency seconds obviously changes and it's not going to be stable. And then here's maybe the inputs to write for, what you get from the C group file system, right? And so each one of these test cases is just like, here's the set of input state that I expect. And then the test basically just runs the code. You say, okay, go read some of these files and run the code, do a little bit of setup. And then it produces this expected file, which is the output from it. And so it writes it. And so I don't write this expected file. What I do is I just run it and say, update the expected file, or fail if it's not the expected file. And then that way, whenever we make changes to our code, let's say we want to add a label, we're changing the expectations. We want to make this better. We found a bug. Oftentimes we'll find a bug, right? And instead of going and having to fix every test case, when we fix that bug, we just say, update this, run it in update mode. And then you just do a diff. Right. And so then it makes things really easy where I just fix the bug and say, I expect like all these files to have changed. Show me they've changed. Right. And so we just kind of stamp these things out with different, it is a lot of copy and paste, but it's actually, copying and pasting in this format, I think has worked out really well for us, where we just kind of stamp these different test cases out. We have a lot of them because they're really easy to write. You just kind of copy one test case, change the inputs to be kind of what you expect. And so that, for instance, the tests for these things, and they're not free, but you can kind of see they're not terrible, right?
Phil, why don't you go ahead and break one and run it, and let's see, what it looks like when you've got a break in one of the test cases.
Do you mean like change the code to do something different?
Let's change the expected file to be
Yeah.
like hi there or whatever.
Yeah, so maybe I'll change one of these labels, right, to say app2, right? So I'm changing the label here. Go test package collector. I love doing a live demo, something I've like never practiced before. So let's make sure the test actually, let's see if the test actually is working or if it's not broken, something else. Could just be broken. Okay, so it works there, right? And so then, you could imagine I changed the code in a way that doesn't match the test file.
We need a little bit more terminal, I think.
More terminal.
More cow.
More cowbell, right? And so maybe this isn't the great, I don't know. I don't love this. Unable to save. This is not what I expected. Oh, here it is. Right. So then you can see, is this the best thing in the world? It's not. Let me show you how we expect the workflow to really work right would be. So I've added everything right so it thinks like this is the way. And then let's see. Say update. So maybe I'll do something like this. So pretend that the test case doesn't match anymore, right? I've made a code change and now it doesn't match what's going to be produced. I can say like, just update this stuff. And then I run it, it's going to run all the tests. And then when I go into source control, it's interesting. It'll show you, hey, look, I made this change. Like it did say before the expected result was, app2, and now the expected result is app1. And so typically when we write a test case, we leave these things empty, kind of a bad practice. We should probably be a little more careful about making sure the test expectations.
Mine aren't empty.
Oh,
I always copy them from other cases.
Yeah. And actually you can see the diffs really easy. Then you copy a test case, you change an input, you add all the stuff to run the test, do the diff. And then you can see, yeah, when I changed this input, I see the output changes in a corresponding way. That's good. So that's something anyone can actually borrow from this repo if you happen to want it for something you're doing.
And there's a pattern to when you're reviewing PRs, you just go look at the test cases and how they change first. And if that doesn't pass, then I'll go change that. Doesn't work.
I have a general question for you. say there's an organization that thinks this is looking pretty cool and would like to try it out. What caveats would you have for them in terms of production readiness? Like, don't try it on clusters this big, don't try it this big, or it's all great, just go for it.
I'd say don't try it. So the size of the cluster is probably going to be less of an issue than the cardinality of what you're exporting in terms of what you're going to blow up, right? Maybe listing, like, this thing's going to list all your pods. Make sure you're comfortable with that sort of thing. Obviously, any new piece of software, don't just run it, on your most important production cluster without trying it. Like, so normal sanity applies. I'd say, be careful about which Prometheus you push this into. Push it into its own Prometheus. I'd say, even not just starting out, you probably want your own Prometheus for this stuff. You don't want to be alerting. You don't want the thing that tells you when something's terribly wrong and alerts you to be also the fire hose for your utilization metrics. So try and create your own Prometheus instance for it. It's probably the most important one.
I would probably add to that, like, run it side by side with whatever you're doing now, and like carefully examine the data, because you might be surprised once you start getting like very high resolution data, what you may not have seen before.
Yeah, that's very true. The sampling, it may look a little, you don't want it to look wildly different. So do a sanity check on that. Any metrics that you're going to make decisions off of, I'd compare to SIG and just do you're not going to need to do all the joins with SIG just to get an estimate, like sum up by names. Like, you can do it at a namespace level, for instance, without doing any joins from SIG. And then compare like the namespace level metrics, make sure they're the same. Maybe do some individual pod metrics, kick the tires. One thing you're almost certainly going to have to do is if you're not using Containerd, if you're using the C groups file path walking, it relies on having certain naming conventions, right? It reads the pod UID from the C groups path. It reads the container ID from the C groups path, and different systems are set up differently. With some of them append everything with .slice. Some of them prepinned kube pods dash burstable dash whatever to the pod name. So if it's not working out of the box, you're going to have to you might either have to understand what it's doing, or maybe you could ping us on Slack and say, hey, I'm not getting utilization metrics. I looked at the C groups. This is what I'm seeing.
The Containerd based stuff should avoid that problem. So you could try that out. I guess another possible thing that we could have on the roadmap is support for more CRIs as sort of a general thing. I wanted to use like a general library, and one didn't exist. So them's the breaks, but that might help out too. We have 1 minute left. So I guess any last questions? Hopefully this was like, I'm not sure if we want to keep meeting in a sub-project meeting like this, or if we can just include this in our regular business in like SIG instrumentation meetings. If that sounds good to people, like, we can just include it in a regular agenda item on our Thursday meetings, update from the sub-project, but I imagine we can work pretty asynchronously. Does anybody have any particular feelings one way or the other now that we've demoed things, we've done the deep dive?
What do you recommend?
I think we can always have another ad hoc sub-project meeting if we need one. I don't know if we'll need regular ones at this point, so I think it's totally fine to just use the main SIG instrumentation meeting for that.
I think that's fine, as long as you notify people in advance of meetings so they can participate if they want.
Of course, yeah. I would try to ensure, like with the last 2 meetings, that we're giving at least a week notice. So
Okay.
Awesome. Okay. Well, looking forward to seeing what everyone finds out. Feel free to leave issues on the GitHub repo, reach out on Slack. We'll just use the main SIG Instrumentation channel, and you can find many of us there, and really looking forward to where we go with this.
Thanks,
Thanks,
everyone.
everyone.
Everyone.